Okay, so I thought this was recording and worked out this whole thing, but it wasn't. So let's try again. So 3.8 derivatives of inverse function and logarithms. So here's my inverse derivative. So the derivative of the inverse evaluated at a point is 1 over the derivative of the function. And this is like composite function. So 1 over f prime of f inverse of b. So here's an example. The derivative of the inverse of f, or sorry, not the derivative. The inverse of f is the square root of x. So when I talk about the derivative of this function at the point 4, 2, it's the reciprocal of the derivative evaluated at the original function at the point 2, 4. So remember, you can see my points are switched. We've switched places with x and y. X squared looks like this. The square root of x looks like this. So we are talking about the derivative evaluated at 4, 2 would be the reciprocal of the derivative evaluated at 2, 4. And you can try that. Like, take the derivative of the inverse, take the derivative of x squared, and plug in 2 and see what you get. Plug in 4 for this inverse and see what you get. Just try it out. All right, so here are some inverse functions that derivatives that we need to know. Some of these we've already used, like this one. We know derivative over original for natural log of x, and I worked that here. So derivative of 3x squared is 6x over the original, and I can reduce that to 2 over x. A new one, when I'm taking the derivative of a base that's a number instead of an exponent, it's like 4 to the x. I write 4 to the x, I keep that, and then I multiply it by the natural log of the base. Right, and then when I have log base a of x, it's 1 over x times the natural log of a. All right, logarithmic differentiation. This makes life so much easier, you guys, so I don't have to do product rule, chain rule too. Product rule, chain rule, and quotient rule here. I'm going to take the natural log of both sides and use my properties of logarithms. I'm not going to take the derivative until I get way down here. So, properties of logarithms. When I see division, I'm going to use subtraction. So, that's the first thing I did. I took the natural log of both sides, so you have to apply the natural log on both sides. And then I split up my fraction into my division into subtraction. All right, then I also remembered that this multiplication right here can be split into addition. So I did that. Then I moved the power to the front. Still just logarithm stuff. Okay, not power rule. I'm just simplifying the logarithm. All right, then I took the derivative of both sides. So derivative of natural log of y is 1 over y, derivative over original, times dy dx. Then I took the derivative of this. Derivative of x squared plus 1 is 2x over the original. I had 1/2, so I put the 2 on the bottom. Derivative of x plus 3 is 1 over the original, minus derivative of x minus 1 is 1 over the original. All right, then I multiplied both sides by y to get rid of that. And so I had y times all of that business. All right, then I went back up to my equation, this green equation, and I pulled what y was equal to from the beginning and put it here. All right, you can just leave it just like that, but that's way nicer than doing product rule and quotient rule wrapped up into that problem. All right, when I see you, we'll try some more. Talk to you guys soon.